Okay, here is the procedures. I want to talk about that. Initially, we run the setup speed heading. We generate the database, 12 headings, 30 frequencies, 5 speeds. We generate that from the Maestro wave runs. This part, that's you generate the database. When you click this compute, you generate the database. So once you have a database, you have all the IOs, and you select wave spectrum, operating profile, C-scatter diagram. You have the response spectrum. Then there's extreme theory from Professor Ochi based on number of cycles, probability of speed headings. This is probability headings, probability speed, probability of wave height, and wave period. And you have this extreme value based on the theory. And every cross study they're using the same equations. It's all Ochi's extreme values equations. You compute the moment of the wave spectrum and have this equation. There's a very good book called Ocean Waves, if you can get it, describe all that. Ocean wave, okay. Which Professor Ochi's Ocean Waves, yeah, this book. Maestro has a lot of coding based on that. You can buy that from Amazon. You can understand how this extreme theory is developed. A lot of classified ABS using exactly the same thing. We coded pretty much based on ABS, a DLA guidebook. Once you have all that, you generate the loads and you run the analysis, do the stress assessment. So that's pretty straightforward. So this talking about you can import, we did that, and review the C-scatter diagram. You go to the file, import, wave scatter diagram. Maestro installation, we're giving some of the samples standard. And you can define your operating profile or you can create one. So using those, if you don't define anything, when you do the design waves, it's using equal probability, so which means every speed heading and every C state, same probability. So this is showing you how do you do the long-term wave design. You see dialog a little, this is the old version, but pretty much the same thing. You define or you keep that. Default using hydrostatic option. How many largest design wave you want to have, and risk factor. That's defined in the Ochi's book. In general, when generate two, because it's a linear theory, when you have the dynamic bending moment, you change 180-degree phase angle. In terms of value, you got the same. One is positive, one is negative. That's equivalent to our sagging hogging moment. We automatically generate two, the one of this, and we add a phase angle 180 for another load case. Spectral fatigue, very similar. You have the general database, and now instead of a vertical bending moment IO, you do the element stress IO, wave spectrum, operating profile, C-scatter diagram, long-term environment. This combination, you get response spectrum. You using the SN curve, some mathematics to operate that, then the minus rule, you get this equation. You can find this equation in ABS rulebook, in DMV rulebook is the same. It's a really nice mathematical derivation from minus rule and all this probability theory. When you have single SN curve or two slope SN curve, you can get this closed solution. But when you have like three slope SN curve, like aluminum, you don't have that. You're just using numerical integration to get a fatigue. So, but for single slope and two slope SN curve, somehow they found a closed form mathematical equation to solve that. So basically, we generate those and generate the database and just go through the process. That's the stress fatigue, spectral fatigue. I'm going to just show you a quick run. How do you run the spectral fatigue? So here I have a model. Let's go to my training materials, Maestro tutorials. I send this one to you as well. So the SFA code, it's the same. You run. So here I just have one speech. It's going to take some time. We generated the BMN file. And so let's run that. You want to override it? I say yes. All right. So on the load the data, the load database, then you go to wave. The default is on the compute stress IO. If there's a little offset, well, I want to make sure I have a minor adjustment, very small adjustment, or maybe most cases there's no adjustment, but we just select that. And you say, okay, I want to generate a stress IO. Now you see this Maestro solver dialog coming out. You don't do any limitation. We want to stress for every element. Say, okay. And ask you, do you want to overwrite? And say, yes. Say, yes. So you can see here, just keep solving the equations about how many times. So because this is one, we have one speed and 1, 2, 3, let's say 12 wave period. One speed, one heading, 12 wave period. And we need to solve phase angle 0 and phase angle 90. So that's 24 FEA solutions to get the stress IO for this. So as you know, the beauty of frequency domains, if you have a solution for phase angle 0, and you have solution for phase angle 90, which in some cases, some engineer, they call real and imaginary. You have two solutions for each speed, heading, and wave. Then you can superposition any result, right? If I need a stress for 60 degrees, I can do superposition of these two solutions. Because of that, we can handle this vector fatigue for any wave phase angle, you can get a solution. All right, so we have that. And if you want to see the database, so let's say any headings, now you can see the stress, right? Because random mouse click, not only we can see the pressure, we also can see the response stress. So that's a little exaggerated because the dynamic pressure. But if you're using this one, the extreme load wave, you got exactly the same. And we have different speed heading. You can see this is a real. That's imaginary. This is look a bit better. So now with this, every speed heading, and we have the stress IO, we can do the fatigue. Go to the define a fatigue load case. So I have defined a second load case is the fatigue load case. That's we're using the wave-based IO. This is called the environment, right? You have water-based load case. Do you have operating profile or not? Okay, so you could probability is 30 years design, and what is the environment? What's the wave scatter diagram? What's the wave spectrum? And so now you define, okay, where I want to assess the fatigue. You can define a group, right? So you can define any location. For example, I say, okay, or you can say, give me the fatigue for the whole ship. Or you say, okay, that location is probably a fatigue issue. I can define a group. It's general group. Okay, this is one guy. Oh, that's everything. So that's just one plate. Okay, if you want interested in the fatigue for everything, and this is the group, you find everything, right? It's all modules. There's one group called all modules. I select that, or I can select group number 6. Which SN curve do you want? At certain location, they have different steel class. Okay, so C class or D class, we have a library. Okay, ABS, DMV, and you can define this is aluminum, Euro 9, and you can define your own SN curve. So you associate a SN curve to a group, then you can define the stress concentration factor. Let's say already define that. Then you say, okay, I have a load case defined. I have stress IO, and I just run it. The first one is the nominal run. That's a still water. But the rest, you can see here, we read the stress. Now the fatigue calculated. This is the fatigue for that speed. That's the heading. We don't really have deformation because this is fatigue. So those areas, the initial screen said, that's probably the problem. You ever have fatigue? This is probably the place you want to check. So you may want to refine this area, get more details about fatigue. So all this gray is no fatigue. This is fatigue damage ratio and so on. So as long as it's less than 1, it's all safe. Over the 1, then you have some issues. And you can also review that number of design years or lifetime. So for 50 years, that's no problem for that load we just run. So today is just a quick run. Once you have an FG model, you balance it, you can generate a database, you can generate the extreme load, you can also create stress IOs and run the vector fatigue. So this is explain that you associate a structure group to SN curve and the stress concentration factor. You define the mission. You can have multiple missions, right? You have full cargo departure and empty arrival. That means you need 2 databases. each database using its own stress IO. So you can run 15 years departure, 15 years arrival, or maybe another 10 years when you're in the harbor. So you can define how many missions for vector fatigue. Then you run it. So generally the Union Wave stress IO, we show that. So this is the global screen. You have the models. You can using these slides to go through how you want to have a quick runs. It's all set up for you. Do a little practice yourself.